Hello and welcome to another video about set theory. So this is about set theory and how it applies to language. That's what this little course is about. We're going to take a moment to talk about everything that we've talked about so far and how this can be applied to natural language. So we've already seen one example of how recursive set definition can be applied to things like creating a list of all the possible words of a language. So if you want to review that, go back and watch the example video about Hawaiian. But you can also just make sets of things that have qualities and they have subsets of things, right? So this is basically applicable to any field, not just language. But you can make a set W, which is the set of all words of French, right? And a set V, which is a set of all verbs of French, right? And that will tell you that V is a subset, or in this case, a proper subset of W. This helps you sort out terms in any field. There's a lot of places where you can apply this in linguistics, but this is basically how you can apply it to any field. What's more interesting is things like this one where you can define infinite sets of things in linguistics using things like recursive set definition. But we're going to talk about something mostly that's pretty different in this video, which is about treating the meaning of a sentence as a statement about sets. So if we think in set theory, what is the meaning of the sentence, "The lamp is red"? Right? So we have something which is the lamp, which we know is, some object, which is a lamp. And what we're essentially saying about this lamp is that it is a member of the set of things that are red. Does that make sense, right? So the lamp is a member of the set of things that are red, right? And so you can imagine that this set of things that are red exists, right? And you can think of this set of things that are red being out in the world. And when you see something, you can make a statement like this, and this becomes true if the lamp is a member of the set of things that are red, and false if that statement is not true, right? And so that's how you determine whether or not the lamp is red. We'll come back to this when we get deeper into these sort of ideas, and this is sort of an oversimplification of how this works, but this is a really good way to think about the meaning of this sentence, as the lamp is a member of the set of things that are red. Now, what does this mean about the meaning of the word red? And you'll see this bracket notation as we move along. This means the meaning of this word, right? The word in the brackets. The meaning of the word red is essentially just the set of all things that are red. Right? So you don't, all that you need to know about red is that it's this set of things, right? And that's all you need to know, right? It's some set that we've decided are members of this set, right? And so if you know what's in this set, then you know what red means. You can think of verbs in exactly the same way. Some verbs at least. Well, most verbs. We'll get into more complicated verbs are like transitive verbs where you have, Ravi hits the ball or something like that. Those get more complicated. But for intransitive verbs like this, you can think of them in exactly the same way, right? Ravi is a member of the set of dancers, right? So if you know the people who dance, then you can assess whether or not this statement is true, right? So this is a formalized way of thinking about the meaning of the sentence Ravi dances. Now, interestingly enough, we can also do negated sentences. So Ravi doesn't dance, all that you're doing is you're saying Ravi is not a member. Remember, we have this lovely not a member symbol of the set of things X such that X dances. Right? So this will only be true if this statement is true. Right? So otherwise, Ravi doesn't dance is going to be wrong. Things get more complicated when we start looking at words that depict things that are not individuals, like all cats, right? So all cats is a set in and of itself. The set of things X, such that X is a cat. Interestingly enough, these join with verbs in different way than things like this join with verbs. So right here we're saying Ravi is not a member, or is a member of the set of dancers. Here we're not saying that the set of all cats is a member of, that's a terrible curly bracket, is a member of the set of sleepers. That is not what we're saying, right? We are essentially saying that it's a subset of the set of all sleepers. And why is that? Why does this one mean that Ravi is a member of the set of dancers, and this one means that every cat is cats are a subset of sleepers? This is a really interesting linguistic question, and this leads us into semantics, right? But the fact remains that if you say that all cats sleep, you're essentially saying that cat 1 is a member of the sleepers, cat 2 is a member of the sleepers, right? So you're saying that everything that suits this definition also suits this definition. You're not saying that the clump of cats all together all have to sleep at the same time. So this is an interesting thing about language, which is revealed by the fact that we're talking about this in terms of set theory. So we haven't been able to explain that thing about language yet, but because we're thinking in these mathematical terms, we've noticed this difference between sentences that look very similar on their surface, right? Ravi dances and all cats sleep look really similar on their surface, but they are actually doing something different. There's a different operation taking place in these two sentences. And we can negate subsethood too, right? So we can say, oops. Right? So this means not all cats sleep means that for whatever reason, the set of all cats is not a subset of the set of all sleepers. So that means you could still have one member shared, right? So we could still say that cat 2 is a member of cats and a member of sleepers. But because cat 1 is not a member, or is a member of cats and is not a member of sleepers, we can say that, not all cats sleep. We can say that. All right, so this has shown us some of the things that we can use sets to do in natural language so far. We'll have some more of these little aside videos where we talk about the applications of these things, and you'll see some more of this stuff in homework problems as well. So I hope you're ready to progress to the next new set theory thing.